Here's the set. Look at that. So cool. Alright, I'll plug it in. Alright, similar setup, just going up slow with the Variac. Just plugged in with the thing. This unit was made in Chicago, called the Master Electric Company. There it goes. It was going. No output. Took some messing around. The front part screwed off pretty easily, and the back part took a little doing. I'm gonna check it out a little bit further off camera, then I'll come back. Alright, I fixed it. It's hard to see. It's just the power cord. The cord was allowed to it's just free spinning in there, so just over time it kind of kept spinning, and then the contacts inside just kind of worked themselves off, corroded off. But fixed it, it works. Here we go. It's hard to see. I'll turn the light out later, but you can see the purple, the violet thing sticking out there. I put my finger. Oh, stop. So you can feel it a little bit. Depending on what you're touching, it shocks you, but right now, it actually feels pretty good. There's placebo. Alright. I gotta take another look at the contacts inside. The whole thing's smoking a little bit. That's great. Alright, let's keep going. Let me hook it up to the O-scope, and we'll check out what I did before. Alright, I wired the output into this high voltage divider, and then the low end into the scope to see low voltage in the scope. I hit the internals here where this kind of spark gap kind of thing. I hit it with some contact cleaner, tried to clean it up a little bit. But here we go. I'll hit it. I opened up. Okay. Look between these two. 111. So super noisy. I'm guessing maybe it's should be about 120 hertz with the input power, and then each of the peaks of the 60 hertz is kind of at least creating some kind of spark that's making it through, delivering energy through that gap into the primary coil and the tank circuit. So if we zoom in, this is just one of those things. This is definitely the tank circuit. Each of these damped sinusoids. So we zoom in even more. So here's one of them. Each of these damped sinusoids is definitely the tank circuit going off. And measuring the output. So this is what the output of the secondary is ringing at. So let's just take a quick look at this. There. So 238. What's this one? 250. So between 238, I measured earlier 260. So in that kind of 250 kilohertz range of resonance at the output of this thing, which sounds about right. I don't know what I did. I did it at one point and got shocked, but right now I'm just getting healed because it's awesome. What's really cool, I don't know how, the actual electrode is glowing a much darker purple. I got some fluorescent bulbs. They kind of light up. We're lighting up the bulb. Here's a UVC bulb. Not quite the same. A little bit. It's hard to see in the video. You can see a little bit UVC. So cool. So, almost, I guess, exactly like a plasma bulb. Yeah. Earlier, I'm not sure what I was doing, but it was arcing directly to my hand and actually zapping me. But not now. Right now, I'm just getting younger. There's a little bit of heat over time, but it's nothing. Really cool. I also noticed in the O-scope, I was getting lower voltage over time, and this thing was smoking, so, I mean, I don't know if it's going bad or what, but nothing really, not a lot of current being drawn, you know, there's not a lot going on in there, so, super cool.